Yes, so this, since it's a first class, what I recommend is to download this Cisco Packet Tracer. So I've already downloaded, so I'll just install, open it. But again, for your just Google it. Okay, well let me just give you direct link. So yeah, this is the same networking. First, you have to register. Just do basic registration. Register and sign out. Okay, let me log in. So let me log in. Okay, so logged in. Uh, let's see all the way. So let's click on Start Learning. Click Start Learning and take the first one, Getting Started with Cisco Packet Tracer. Just click on it. Just click and we'll see. Here, just if you're not added, add your course. Enroll, whatever. For me, already enrolled. So I'll resume the course. Just enroll the course. There is an option somewhere here, download. So let me see. Install first. You see, you go down, you will see here. Download Cisco Packet Tracer. In the course only, they provide the first step, install Cisco Packet. Just go here, this one. Yes. Go here, you can see this like this. Just click on it, and I think it depends on your computer, Windows, whatever the computer is. Right? I think this one, yes, you can try 8.2.2. Yeah, just download it and basically install however Windows is like. Yeah. So I can save this link maybe later. Okay. Maybe because of internet. Again, you can try later, but so let me cover the class. We'll try later. You download and stuff. So since it's a first class, what I recommend is you just have to understand the basics of computer networking. Let's say computer networking. So that's what we'll try today. So typically networking means it's all about how two devices send or receive data. So that's what networking is, like how two devices, of course, more than two, but typically. So networking is that only how two devices can send or receive data. So that's all networking. So let's go Cisco Packet Tracer. I'll show you. Let me take one computer. So let's say I'll take this computer. You see, I'll just give a name, C1, computer 1. Maybe I'll take another computer, C2. C2, example. So typically we know that computers have the cable connections. You can make a wire, one wire from here to, let me just make a wire, here to here. Typically you can connect like this. Now you can send the data from computer 1 to computer 2. Typically that's very normal, very easy. Now let's say you add one more system. Example, I'll add one more. So I'll tell you the problem. So when I add one more, it becomes, we call network. So that's what network is. Network is a bunch of devices connected with each other. Again, I have to give the connection from here to here. Okay, so let me just here to here again. No functional ports. Let me try this. Yeah, I have to connect this. I have to connect this. Then all three can send and receive information. It's very common. Again, now let me add one more computer. Now what do I do? Again, I have to do like this, this, this. Now I add one more computer. Now you start to see a problem here. The problem is you have wires more, like you have to connect everything. It's like so complex, so complex. Now we had one more computer, more wires, one more computer, more wires. So this is the problem. So that's why we created a solution. They call something called switch. Because of the problem is this: when you add more computers, obviously you need to have more connections. Like it gets even more problematic when you have more computers. You see, I have to add all the lines. One more computer, all the lines. One more computer, all the lines. So that's where switches came. Switches are like this. Let me show you. A physical device, something like this box. What switch does is, switch, actually before switch, we should know hub actually. Hub. Yeah, hub. Let's see hub also. There is a hub, this one. Hub. What hub does is, instead of connecting each computer to each other computer, hub sits in the central. Okay, hub. It's a central device where all systems are connected. Where all systems connected. Let me show you. Example. Let's take the same example of these three, five, six computers. I'll take 1, 2, 3, 4. That's it. All you have to do is, I don't need to connect each computer to another computer. I'll just simply connect to hub. Connect to hub. Connect to hub. And finally, connect to hub. Now this is easier because when you add a new computer now here, it's very easy to communicate in the network because you can simply connect, you can make only one connection. That's it. The one connection is this only, is to this. That's it. At least wires are reduced, not more wires. It simplify the process. You can see. Still, it's the same only, but the idea this is simplified. Now, if you add any system, all you have to do is just add one connection to the hub. That's it. That's it. Now this system, sorry, this computer can send data to this via hub like this. It goes like this, like this. It goes like this, like this, like this, like this, like this, like this. So now this is simplified mostly. But the problem with the hub is, at least better solution of networking, but the problem is hub actually we call broadcast the data. They call broadcast means it sends to all devices. It sends to all devices connected. For example, let's say you have a message, you want to send this message to this. Let's say you want to send message this to this. What hub does is, you first send the message to hub. Hub sends the message to all the computers actually. So all these computers will say like, okay, this is not my message. They will reject the message. But this computer will accept the message. Hey, this is my message. It's like a newsletter, a letter. Let's say I want to send letter to you. But there is a third person here. I send the letter to third person. The third person sends the same letter to each one of you. Copy, basically. So obviously these people are not receivers. You are the only receiver. So these people will reject it. Like, hey, this is not my letter. But you accept it. Still, my message is reached to you. But the problem is, if there is an attacker here, they will accept the letter. Oh, this is my letter only. So that means they can see my data. So that's a problem. So that's what the point you should know. The problem is hub actually broadcasts the message to everybody. Broadcast the message, data, whatever you call it, to everyone. Everyone is connected. All. So that's why there is a concept came called switch. What switch that is? Switch is also very much same as hub. I'll take same computers, let's say. Example 4. Sorry. Switch also very much same, like this one. Same connection, same centralized. Let's see, come. Sorry. Here. First, let me complete the connections. Switch also very much same to hub, but switch does you unicast, meaning only send to the corresponding, only send the message to right recipient or right destination, right recipient. For example, if I want to talk to computer 2, let's say from year to year, the message will go to year only. It does not go to this. So in a way, privacy is there. So whoever wants to send, the message will go to that particular person. Like directly, my message goes to you via switch, not to other people like you. So in a way, it's better compared to hub. So nobody can typically attack that because whatever the destination I give, it will go to that person via switch. Awesome. Yes. Any question so far? Is it clear up to this point? Any? Yeah, we are just recap only. Basically, we are thinking about networking, how networking works. The whole idea of networking is how two devices talk to each other, send or receive messages. The earlier days, we have to connect like this, connect all system to all systems. That's not a scalable solution. Then we come up with a central device. We called it hub. Hub we can connect to every computer. But the problem with this, hub broadcasts the message to everybody. So that's a problem. So that's why they came up with switch. Switch sends the message only to the right recipient, whoever the right recipient is. So at least the problem is solved. Like. But one point you have to know. One second. So we call this a network. Let's say we call this a local network specifically. The term you have to use. I will write it down. Local network. Switches can be used. Can be used within networks. We call within local networks. So let's see this. Let's say I have my home. In my home, I have 4 computers. I connected via switch. Now this computer can send message to this, can send message to this, can send message to this via switch. It works. Now let's say I have an office somewhere far. I have another office, maybe somewhere. That office contains, let's say, 2-3 computers, maybe 1 laptop, something. It doesn't matter. Same. I have switch there. Same connection, same thing. Everything is same. Sorry, just a second. Okay. So this is another office, let's say. So this is one network, local network 1 we call, let's say. This is another network, local network 2. Now let's say I want to send a message from year to year. So that is the idea. I have 2 different networks. This is more local network. This is also local network, but different location, not the same. Now, what do you do? What do you think we can do? Do you think can I add one more switch here in central and connect these two? Can I? No, you can't because switches only works within the networks, not outside. So this is where there is a concept of router comes. Router, like this one. Something like this. Yeah. So this is where the concept of router comes. What router does is router connects 2 different networks. So maybe I'll add that point. Router, it connects more than 2, but let's say 2 different networks. Let's think about our own example. So we are using Wi-Fi, right? So how are we connected Wi-Fi? So if I want to send a message to you, let's say if I want to send a message to you, I will send a message to via a router. But router also acts in home routers, actually router and switch both combined actually. They are not different, local. But in companies, switch is separate, router is separate mostly. But in our local, let's say Wi-Fi router is there, right? That router act as a switch come router. So if I want to send a message to you via Wi-Fi, my message goes to the router will send message to you. Now, if you go outside, use your mobile, some other internet, then I cannot communicate with you. So that's what the router is. So router also very much similar to switch, but it's connected different networks. Maybe I can give some links. So let's see. I'll just connect here, connect here. Same, I'll connect here, connect here. So now I can send a message from this computer to any of these computers. But the message goes like this, goes to switch, switch to router, router to switch, switch to the right recipient. Okay. So far, any questions? Anything? Which one? See, installation we'll have to see maybe later only. But topic wise, any questions? Is that clear? Anybody? Okay. Now, if you think about the internet, what is internet like typically? So internet is nothing but these bunch of local networks only, like this example. So there are thousands or millions of local networks. They are all connected. That's what internet is. When you go to Google, let's say you go to browser and type google.com, what happens? Let's say first I enter the message created in my computer. My computer, it goes to my router or Wi-Fi. Router also connected to another router. We call internet service providers, ISPs like Geo, Airtel, whoever that is. They have their own router. So my router to their router. Now their router to another router, another router to another router, another router to another router, so on it travels. Finally, it reaches where google.com is present, mostly in the US. So it goes to the US router. I mean, physically, like message goes physically, like wires or mostly wires only. It goes to the US, some state or some city. It goes to that router. From that router to one system is there, server they call. It goes to that particular system. Hey, somebody is requesting my page. Then response comes. Response also same way. It goes here. It travels all the way, comes to my system. This happens like just like that, right? Within milliseconds. But if you zoom in or slow motion, the message goes here to here to here. It travels like all these kilometers. Finally reach there, get back here. So that's what internet is. When you say internet or do something, every second, every millisecond, data passes like all the way, mostly via cables, fiber optic cables or different cables. But at our home, we use Wi-Fi, but in real life, it's all cables. Like your data physically go to the cables. Anything, any website, not necessarily google.com, any website you visit, any internet task you do, your messages are going like within milliseconds, going very fast. So anyway, internet is nothing but a network of networks. So that's what internet is. Like there is no magical thing. I mean, when we see internet, we think like magic, hey, something happens. But it's not magic. It's just simple of connections of these local networks, thousands of local networks, millions of local networks. They all connected. That's what we call internet. All connected. If you go back early, only few people have local networks, maybe 10, 20, 30. Then people are like a building like, okay, let's create this network. Let's create this network. And nowadays we are in modern world, so everything is connected to every other computer. So maybe I'll write that point. Internet is nothing but a network of networks. That's all internet is like. The reason why it's important, cybersecurity is all about that only. Like, hey, when data goes from year to year, your job is to data goes securely. So that's what cybersecurity is all about, right? So when the message goes from year to year, you have to secure. 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 You have to secure at each layer. Then finally, the message goes to the right recipient without any modifications or corruptions. So that's what cybersecurity is all about. Like it's securing your data. Like yeah, so that's the high level idea of how internet works, what network is, what router is, switch, router, hub. So maybe I can tell you a few more things, small devices, which you already know, like Wi-Fi. Yeah, Wi-Fi is easy. Wi-Fi only works for local device, not like the global. For example, think about your phone. How your phone, you're making voice calls because your phone has a SIM card. The SIM card sends the signal to the local tower. So that's where you have a signal length. If there is no tower locally here somewhere, you will not get the signal. So you cannot even call, you cannot do anything. Let's say there is a tower here. When you make a phone call, your voice data goes to that tower first, that tower to another router, another router, another router, and so on. Finally, it reaches that recipient tower to the phone will come. So that's how you can speak. If the tower signal is very less, obviously the voice is like little break, breaking a bit. Hey, I can't hear you. So because of this problem. If the tower signal is very full, like close, I'm close to the tower, obviously I get full signal. Then of course my voice will not have any problems. So at the end of the day, your phone data is data traveling, your internet is data traveling, everything is data traveling, even Bluetooth speakers, let's say your headphones, right? How does like your phone from here to here, my data is coming. Bluetooth is also in a network, but we call personal network. So data sends from here, it emits the signal. My Bluetooth device captures that signal and gives to my device order. If I'm far away, then signal is weak. So that's why when you go far, you will not hear the signal. Bluetooth has maybe 50 to 100 meters of range. Wi-Fi can have more. Radio signal, phone signal can have even like many. And radio waves also we call. That's even space and stuff we use most. Yeah, mostly like that. Smaller range is Wi-Fi. Larger range is that radio waves, like space stations, internet, all these things. Yes, any questions so far? Up to this point, any questions? Let me know. Okay, now I'll tell you a simple concept you need to know. One, something called MAC address. MAC address. MAC means media access control, I think. Doesn't matter. MAC address, control address. Another is IP address. IP address you must have heard a lot. IP address. Internet protocol address. Something like that. Something like that. So let's see what is MAC address. So when you go buy a laptop or phone, let's say, there is a small device called NIC, we call network interface device. It's a physical device, something like this. It's present on your laptop, it's present on your phone. So this is a physical device, physical hardware device, something like this. What this device we call network interface card, we call network interface card. So what this network interface card has, whoever is created, manufactured companies, they assign an address. They assign one permanent physical address for that hardware, for that NIC. That is what MAC address. Yeah, so basically MAC address is like a hardware address. Whether it's a phone, whether it's a computer, there is a small network interface card. It depends on the phone or even USB dongle also will have a small network interface card. Whoever is designed, whoever is manufactured that network interface card, they assign a small address, they call physical address or MAC address, and it's unique across all. It's unique, like your fingerprint globally. Just like your fingerprint is unique across all people in the planet. Same thing, MAC address also is unique across all the computers, all the devices, entire thing. Actually, a typical MAC address example is like this. It's in hexadecimal, but if you don't know, it's okay. Something like this. Something like it. It's in hexadecimal format. It's a 48 bits quality. Again, we'll see if you don't know hexadecimal, decimal, we'll have to take a class on that. But think like this, just like an address, some address, something like this. I can also find my MAC address. You can also find it. So maybe you can run these commands. You have Windows, right? So let's see. Find my MAC address. Windows, Windows command prompt. I think you can try ipconfig, something like that. Maybe you can try this side, something like this. So you will get something. So I'll try on my, you can try this actually. ipconfig/all. You will get like physical address. You will get some address there. So I can try mine. Mine is Mac. So Mac is probably different. So for me, IP doesn't work. I have folks. I have folks. So something like this. Let me open it. Yeah. So this is my MAC address. It's permanent. It's permanent. It can be, I cannot remove. It's permanent with my laptop. Same thing you can try on your phone. Your phone also have MAC address. Like every device has MAC address. Without MAC address, you cannot even send the data. Because without that network interface card, we cannot send the data. If you attach network interface card to this table also works like your phone. It's no different.
But what is subnet?
Subnet mask is a tiny concept in idea of subnetting. Subnetting means if you have a large network, you divide into subnets, like smaller networks. For example, let's say I have 100 people here. What I do is I'll create like 10 people per batch. So 10 batches. Each batch I can call a subnet. Subnet 1, subnet 2, subnet 3, subnet 4. Dividing. Large network, you divide smaller network. That's what subnetting, right? Concept of subnetting. So subnet mask is more like a small idea to identify that network, that group. Right? That's what subnet mask is. We'll see. We'll come later, subnetting. Yeah, so that's the MAC address you should know. It's a physical address, unique globally created by device manufacturer. That's all you need to know. I think that's it. It's permanent, it's unique. So that's all you need to know. Then coming to IP address. Let's see, IP address you hear a lot. So IP address is it's a temporary address. It's not permanent. It's a temporary address given to you when you connect to a network. When you connect to a network, any network. If you don't want to connect to a network, you will not get any IP. You don't need IP. But if you want to connect to a network means a bunch of computers, then you need an IP address. So that's what IP address is. It's not unique. It may be unique within the network, but outside it's not necessarily unique mostly. It's a, let's call, there are two types also, IPv4, IPv6, but we'll see maybe later. IPv4, IPv6. Mostly IPv4 means v4 address, something like this, 192.168.1. Something, whatever. I can see my address also. You can also see it on your computer. Windows, I'll just have to check, but I can show you my Mac first. So I go to Wi-Fi. I go to this, network settings. There you go. Yeah, there you go. So this is the router address. The router I'm connected to. Same also for you also same. This is mine. If you look at your computer, instead of 60, you will get something else. 30, 20, whatever. Difference. But everything is same. 192.168.1 probably same. The 60 part, each one gets different, like probably 10, 20, whatever that. So this is what IP address. But local address we call local IP address. We'll see types, but just want to give you an idea. This is router address. Router address is same for everyone, but your computer address is different. I can even see your data. I mean, not see, but I can ping you. For example, I can ping, let's see, I'll try random, 23, I'll try, get or not. 23 is not available. Again, I have to guess it for all, I have to try all. But if you can tell me your last digit, I can just ping and see get or not. Something like there. 56, okay. 56, right? It's actually not active, which means your Windows probably blocked the incoming traffic, like mostly. You can ping me, just try ping, what is mine? Mine 60, I think. Try ping me, ping this, you will get reply like this. Ping, just my IP address, just enter. You will get the reply. 1.6, 1.6, 1.60, 60. Your reply coming? I can also see that reply. I mean, I can also, sorry. Send packet, yeah, 64 bytes you can. Let me see. Just stop the ping. Do it one more time. Just stop the ping first. If you're doing, just stop it. Let me. Now do the ping. Do the ping one more time. You can see somebody 58, I guess, is coming. Okay, yours. 60 is mine. Again, you doing it? I can also see it. 56 not coming actually, but again, I'll have to wait maybe to capture. Yeah, 58, 58, 26, 56. Yeah, it's not coming, but it'll take some time. Maybe I'll have to clear it. It's a tool of Wireshark to understand what Wireshark is it. It's again tool. We'll see. Yeah, it's a network analysis tool. Sometimes it takes some time locally. Plus Mac also there are a lot of bugs actually. But just want to show you everything you do. There is a log somewhere. You can see. You can observe. Yeah. You can try 56 messages as well. 1.56, right? Yeah, there are no messages as such, given the current thing. But you will get it like at some point, like, will be there. Yeah, so that's what the IP address is. Every computer will have MAC address by the creator. I mean, whoever created the computer. IP address given by the router actually depends on the network you go. If you go to another Wi-Fi, you'll get different IP. If you go home, you get different IP. You go here, different IP, different IP. So IP address also we have types like private IP, public IP, IPv4, IPv6. I don't want to tell today, but maybe further classes we can understand the differences between V4, V6, local IP, global IP, public IP, private IP. So some things are there, like. But at least some idea you get. You need both MAC address and IP address to send the data across different devices. So without IP address, you cannot identify it. Without MAC address, you cannot send the data. So that's why these two addresses are very required to make any transactional services. Yeah, that's all about computer networking in a way, summary wise. I mean, high level. It's all about sending data from A to B. But you create a network in a way that's scalable. So that's what internet is scalable. You can go anywhere, access internet because of the switch, because of the router, because of the MAC address, because of the IP address, because of the cables. Again, I did not tell you more about cables, but cables also a big part of cables, like physical cables. Like there are different types of cables actually, like fiber optic cables, all these cables are coming, yeah, like these. Again, it's all physical hardware thing. And for you, not required much, but it's better to know. Let me write it here. Different types of cables on networking, let's see. So some are costly, some are cheap, some are broken, some are twisted pair, more cat piece cable, and coaxial cables come, then fiber optics, fast, USBs, you already know, USBs, console, HDMI, Thunderbolt, DisplayPort for Mac mostly. Yeah, so these are mostly internet. We use fast transformation, fiber optic. Fiber optic is what used because for high speed, long distance you can cover, but cost, right? Coaxial is very old actually. Back in days we used to have copper, everything. Good also, but heavy, it's heavy, like management is very high. Twisted pairs also we use like into Ethernet, all these things. But again, if there is electromagnetic field, then the data is like bad. But yeah, if you have interest in physical, we can learn more about it. But that's not scope of our ours is more software, not hardware. But you can try that. Even ND delight, you can try shorts, yeah, something like that. Yeah, you can see its type also speed. Coaxial, you can see 1 Gbps. Fiber, you can have 100 Gbps. Even nowadays with Elon Musk, Starlink, it's even like 800, 900, those are even higher satellite data. Like you can see more, this one max range is 40 to 100 kilometers. You can cover like very band network. This is more like a 2 kilometers, these, mostly we use this for internet. Fiber, this is for internet, real life internet. The others maybe use, it depends on your local. If you go to some colleges, old colleges, they might use these things. Again, even to this day also I've seen people use those in colleges, old colleges mostly. Because of cost, cheap, these are costly, like fiber is costly. Yeah, so that's the idea of, I think, networking you need to know. Maybe the next topics I would like to do is, like as you said, first is maybe subnetting. Subnetting is a good topic to understand. That's one. Then there is a concept of we call it like, a NAT, network attestation translation. Private IP addresses deeply, private, public, etc., etc. You get that. But for today, what I recommend is just go to the Cisco Packet Tracer. Just create a small computer and try to give you the IP address to it. Like for example, I double click, this will open up. I go to probably desktop. I go to IP config. So just give some IP address. It's 192.168.1.5. Just click on here and save it. That's it. That means this computer is active now. Similarly, I can take another computer. I can also give, let's say I'll give, sorry, 192.168.1.6. I give, click done. Now this is also active. Now I can send data. Let's do one more also. Simple, like so. Yeah, be 192.168.1.8, let's say. Now I create a switch, simple switch. Now I can connect it, something like this, something like this, something like this, and this. Once it's connected, you go here, simulation mode. There is a simulation mode here. Click on it. This will come. First, let me hit this, turn off all. Don't need all these. You only need ICMP. That's it. Okay. Yeah, this one. Now you can click on a message here. Click here, and click here, and you play this here. The simulation will come. Just a second. First, they just have to wait. Let these yellow dots connected white. I mean green. Okay, now it's green. I click a message here. Here. That's it. I just play it. Just wait. So you will see the message goes from, you can see computer to switch came, switch to back recipient comes. So that's a request. Now response. Response back to switch. Response means acknowledgement. Hey, I've received your message. Back to computer. That's it. A simple networking thing. So real time also works same, but physical device you interact. That's all. You can send message to here, here to there. Yeah, you go play with the thing. You can even see each message, but we'll see later. Yeah, just play with it. That's all. I think you will learn more about networking if you play with the Cisco Packet Tracer. You can see message goes to two devices. This says no. This is then goes back to reply. Yes. Yep, something like that. Awesome. Yeah, just play with the networking a bit. Once you get like, sorry. So once you're comfortable with it, maybe tomorrow we can, next session we can go for these topics. It depends on your interest. As I told you, roadmap will spend 7 to 10 days understand the networking. Because if you understand the networking, cybersecurity is not that big deal, right? It's very easy. But understanding networking is the core of entire cybersecurity. If you know networking well, I think cybersecurity is piece of cake. Like you can understand anything. It's not that. It's not about learning tools or anything. Tools are just helpful things. By knowing the tool, you will not achieve any task. But by understanding the foundational grounds, you will understand it. Uh, I would say scripting, but that is not like a full coding. Maybe some scripting is definitely needed. If it's again, the more coding knowledge you have, the better you become. That's all. But doesn't mean that with coding only you can achieve tasks. You can achieve the same task without coding also, but adding coding you automate it, right? So let me ask you this. If I ask you what is 19 times 21, you will not be able to tell immediately. But if I give you some time, you will tell, right? So that's what coding is. Coding is like automating your pipelines. You can achieve the same goal without coding also, but it will take more time. If you do coding, it will take less time. That's all. So that's why I recommend some scripting, very basic, not too much basic. But without coding also you could do same task. I don't see a problem. Yeah, maybe next session we'll do again. As I told you, 1 week we'll focus on mostly networking. Once we are very good at networking, understanding each thing, everything, then we can go for the hacking modules. Hacking is also all about networking only. Defending, we'll see those things like. Yep. Before I close this, any questions? I'll make a notes. I already created the notes. Again, I can send you. Let me show you. Whatever the concept we just discussed, there is a notes for it. We only created like, so let's say, first is, sorry. So this is Mac understanding deeply. Like if you want to go deep into Mac, this is the Mac. Yeah, I'll send you maybe some necessary notes for today. Networking basics. That's it. Yeah, I'll send you these notes today. Networking basics. Whatever we discussed, so think same only, but a little bit more examples, little bit more details. That's all. Switch again, same, but maybe some real life examples would be there, so you will understand what's going on. And just you can see you can ask for answer questions if you have interest. So, what do you think a network is? You can pretty much say this is the right. What does app do? Sends data only where it's needed. Every device. That's it. Why is app not used much anymore? Because of its data to everybody. What's a switch? A smart hub that sends only the right place. right device. Something like that. I'm pretty sure you can answer 90% of things. Yeah, maybe some things maybe you may not be able to answer, but that's where you learn things. But I think you can answer all 10 here. Yeah, okay. I'll send this. We'll connect like the next session.